First of all, thank you very much for inviting a gas network operator in the lion hen of the renewable electricity producer. Before talking about hydrogen, let me just make a couple of comments on, let's say, on already how gas and the natural gas grids are, let's say, sustaining a lot the introduction of renewables. So first, allow me to say that I don't agree with the sentence that gas drives the prices of electricity high. At least what we have seen during the summer is that we had an increase of the electricity wholesale prices for 100 to more than 200 euro per megawatt hour electric, remaining stable around 150 in the second part of the summer, while gas prices have been flat, never moving, and less than 40 euro per megawatt hour, and the HENEX gas prices in Greece were even a little bit lower than TTF. So let's say, I have to say that at least when we look at numbers, in this moment we have many phenomena, not only, let's say, the structural cost, of course, of producing electricity with gas. Let me also add that this summer is an example of how much, let's say, the volatility of the renewables have been really compensated by the presence of gas in the grid. Over this, for instance, in the month of September, I was looking at the days in which wind exceeded, let's say, 30% of the energy mix, and I think we can count them on less than the fingers of two hands, while on more than 30% of the days, the production with wind was less than 10%, if not 5%. And gas has contributed gas electricity production from 20 to 60%, so with big swings on a day-by-day basis. And these swings are possible because you have a network which store gas. So we already store renewable in a way. Simply, you don't see it because the problem doesn't appear, because the gas is there, stored in the pipeline, and enable the system to compensate the renewables. This has been even more accentuated by the fact that this year we had, let's say, very strong pipe imports and less LNG imports. And why I'm saying that is because the pipe has been very flat this year, because it was very cheap, Russian gas, flat, but the electricity production from gas is not flat, it's concentrated late in the afternoon, and so we had a big variation of the line pack in the systems, so the system absorbed a lot of gas during the day, in the early hour of the day, and released this gas during the late hour of the day, so effectively working as a storage, again, in this case, for solar electricity. So I think that more and more we need to understand also how, let's say, having an infrastructure which transport and store molecular is de facto already sustaining the electricity grid as it is, not with addition. And so knowing that there is a hidden flexibility that is used without a cost, and without which, or if we exceed the ability to make this flexibility available. And last point before is also that we often observe that when we have a lot of wind, the gas consumption don't go down correspondingly. We have export, because we have also locational constraint on where the power plants are located, as Mr. Manusaki said. So let's say the complexity is big. And when we talk, of course, about hydrogen, we talk about something that is a very long-term, far away from tomorrow. But certainly, let's say, what we observe today with gas, methane, is applicable to hydrogen in the sense that when you have a gas in the system, like long-distance pipeline, you have storage. So when you convert electricity in a molecular, you make this profile much flatter. And when we look at consumption of energy, Germany has a consumption profile for a gas energy that is 80% flat and 20% flexible. So they needed to receive a flat energy, which of course you cannot guarantee with gas, with wind and solar. And so converting it, I'm not talking about converting it in the hours where the prices are negative. It's not efficient. You need really to think long term to have dedicated renewables, but these are additional renewables that can be exploited, flattening the production profile and creating something which, on 1,000 kilometers distance of pipelines, not only is much more convenient in terms of unitary cost of transportation, but it also provides this storage that the electricity is struggling to generate. So what I think it's important is to acknowledge that already now we have a storage of electricity in the gas system. It's going to be squeezed more and more, because the more the electricity demand increases and the more the swing increases, the more our system is stretched. And therefore, also, let's say, sometimes we don't make all the elements in the sum. We calculated the sum of the elements of the electricity, storage, transportation, and we forget that there are elements in the sum which are there, but they are there as long as the pipelines are used, so we have sufficient imports, and so we can use sufficiently the line pipe for a swing, and we can guarantee the gas to be there late in the afternoon when the wind goes down.